Yeah, so let's start the class. So, as I said, in this class, we'll discuss some concepts of calculus which are relevant to physics, of course,
Mm-hmm.
to understand the graphs even better.
Yeah.
So, I'll just put the heading as calculus in physics.
Mm-hmm.
So, let's understand few things. Slope. What are the various formulas you know regarding slope? Tell me all. Can you?
So you can do rise over run,
Hmm.
or you can just do
Okay. Rise over run. What else?
yeah, the change in y over change in x. It's the same thing. That's like the derivative. The derivative on dy over dx.
There is one more formula. Tan of
Mm. Tan of
tan theta at that point. Correct? Well, it's like if there is a curve like this, and if you want to find the slope of at a particular point, you have to draw a tangent
mm-hmm.
and the horizontal angle theta, tangent of theta.
Mm-hmm.
So I think we discussed like if theta is between, if it is increasing from, if theta lies between 0 to 90 degrees, tan theta is
Positive.
positive. If it becomes obtuse, let's say 190 to 180 between, tan theta is
Negative.
hmm. And exactly at 90, what is happening?
It's 0.
Vertical line it is.
Mm-hmm.
Correct? 90 degrees means maximum slope. Tan 90 is infinite, right?
Oh yeah. Sorry.
So vertical line. Correct?
Mm-hmm.
Okay. Horizontal line, theta is how much?
0.
0. Slope is?
0.
Hmm. So I'm writing m is 0. So slope starts from 0, and as it approaches 90 degrees, it becomes more and more. It increases
Mm-hmm.
and it becomes like infinite at 90. So that is the matter. So let us understand what is meant by dy by dx. Change in y upon change in x, correct? So it's like y2 minus y1 upon,
X2 minus x1.
okay. In the graphs, whenever you are doing this, whenever you are trying to find the slope, let's say x versus t graph, let's say this is the path from point A to point B.
Mm-hmm.
See, notice something, x2 minus x1 quantity, okay, is always positive, right?
Yeah.
So this is always positive. So the sign of dy by dx, sign of slope, whether it is positive or negative, technically depends on this y values. So if y increases, slope is
Positive.
positive, good. And if y decreases,
Slope is negative.
slope is negative. Okay. So this is the condition. So if dy by dx, if I say it is positive, that means y is increasing. Okay.
Increasing.
Similarly, y is
Decreasing.
Now let's say if I write d2y upon dx square. If I say if this is value is positive, can I say dy by dx is
Mm. Positive.
increasing? Okay.
Increasing. Okay.
See, whatever is there here, if it is positive, this
Mm.
value is increasing, correct?
Increasing. Yeah, you're right. You're right.
So d by dx of it is dy by dx.
Mm-hmm.
So this quantity has to increase.
Increasing. Yeah. Makes sense.
You're getting the feel?
Yeah, yeah.
So similarly, if I write like this, what is this called?
So then dy by dx would be decreasing.
So dy by dx is decreasing. So dy by dx is what? Slope.
This,
So for the above case, slope is increasing, correct?
mm-hmm.
M value is increasing. M means slope.
Yep.
So slope is decreasing. So whenever concavity means we are talking about second derivative. Okay.
Yeah.
So I'll write it here. Okay, 1 second. Let's come to the next page.
Mm-hmm.
Uh, yeah. So when I write like this, d2y upon dx square describes what?
Concavity.
Concavity of what type of function?
This is the y function on it.
Y and x are related, right?
Mm-hmm.
Y versus x. So if I write d2v upon, let's say d2x upon dt square describes
It's all
concavity of
versus time graph.
that graph. Okay, concavity of x versus t graph.
Versus t graph.
Hmm. Yeah. So if second derivative, since we already understood that second derivative describes concavity, correct? So there are two types of concavity: concavity up and concavity down. I think you know.
Yeah.
Concavity up means this value has to be positive or negative.
Positive.
Positive for concavity up. Okay,
Okay.
concave up. How will the graph appear?
Want me to draw it, right?
See, I think I told you. Yeah, it's like a ball. U up for U. It will be like this. So this is for d2y upon dx square is positive. What about negative case?
Then it'll be concave down.
Diagram will be. Notice something. We don't call it as parabola. It can be anything.
Yeah.
So I think you know how to remember this. Up means U up. Okay. Down means the opposite. I think it is clear.
Mm-hmm.
Yeah, like that you can remember. So it doesn't have to be entire thing. What do I mean by that is, let's say even if I draw like this is some graph. What shape does this describe? Concave what?
Down. Concave down.
Yes, concave down, right? Hmm. And even if I write something like this is
Concave up.
hmm, concave. Okay, let us check our understanding. Let's say there is a statement. If slope is negative, then second derivative has to be negative.
Yeah.
Question is always, sometimes, never. Which one should be answer?
No, always, sometimes, or never. If slope is negative, then the always.
Well, it appears as always because negative and negative, right? But it is not always. I'll tell you why. See, there are only two cases, right? Regarding concavity.
Mm-hmm.
Yeah, regarding concavity. So either it should be up or either it should be down, right? let's analyze that. I told you that a part of this can also be assumed as concave up, correct?
Yeah.
Focus on the left side.
Mm-hmm.
What is happening? Slope. Is it positive or negative?
Negative is
Negative.
decreasing.
What is happening on the right side?
Slope is positive and it's increasing.
Yes, increasing. What about left side? Here,
Slope is increasing.
slope is positive, okay?
Yeah.
Function is increasing.
Mm-hmm.
Function increasing. Therefore, slope is positive, okay? Left to right.
Mm-hmm.
What is happening on the right side?
Slope is negative.
Slope is negative. So if you compare, if you analyze each individually, what did you notice?
That slope can be positive, but it can still be concave down.
Slope can be negative, it can be concave up. Slope can be negative, it can be concave down. Same. Slope can be positive, concave up, concave down. Slope can be positive, concave down. Okay. So what is the appropriate answer for the original question?
Sometimes.
Okay. This is some misconceptions. These are some misconceptions.
Mm-hmm.
Okay, I hope it is clear.
Yeah, it makes sense.
So, note, slope, positive or negative, doesn't describe the concavity. True or false?
Mm-hmm.
Doesn't talk about concavity, correct? Whether it is positive or negative, doesn't matter. It can be more,
Mm-hmm.
both.
Yeah, that makes sense.
Okay, next. Yeah, this is about calculus. If you understand these things, it is easy to interpret the graphs. Now let's talk about some basics regarding graphs only. Since there was a question in the homework, it's like, I don't know what is it, like. Let's say it is a straight line, okay? Compare the slope at point A and point B. Is it greater than, less than? What is it?
Since it's one line, could you say it's the same?
Okay. So let's say this is a x versus t graph, okay? What can you comment on about VA and VB? Velocity at A, velocity at B.
Since the slope is the same, it would be moving at the same velocity at both points. Constant velocity at both
Constant
points.
velocity. What can you say about acceleration?
Acceleration would be 0 because it's moving at a constant velocity.
Okay. So acceleration in this journey A to B is 0. So that is the thing.
Yeah.
You'll understand when you check the homework, like I have sent some corrections in the homework. Okay, next thing is, yeah, I think that's enough for the graph. Yeah, if you understand what I've discussed so far, that will be enough for graphs. Okay.
Yeah.
And one more small thing. Let's say graph is like this. Now let's talk about from point here to here. Okay. Point A, point B, and point C. Comment on slope at point A, point B, point C.
So at point A, the slope is positive because the function is increasing. At point C, the slope would be 0. And then at point B, since the function is technically decreasing, the slope would be negative.
So it's not about increasing or decreasing, okay? We are talking about instantaneous points, right?
Oh yeah, so that point slope is Negative.
This is positive. This is horizontal, 0.
Yeah.
Here it is obtuse angle. Okay, that is why it is negative.
Yeah.
Yeah, so basically the concept is it was positive on the left and it became negative in the journey. Positive to negative. Somewhere it has to cross 0. Make sense? Positive to negative.
Yeah.
Somewhere in the middle, there has to be a 0.
Mm-hmm.
I mean, assuming that function is continuous, things like that. I think.
Yeah.
Okay. Okay. In trigonometry, do you remember this formula sine 2 theta? Double angle formula.
Mm-hmm.
2 sine theta multiplied by
I can't remember. Sorry.
cos theta. We are on the page number 3.
Yeah.
Okay. This is right. 2 sine theta cos theta.
Mm-hmm.
Yeah, this is important formula. Okay. I mean,
Mm-hmm.
this is relevant. Coming to chapter number 3.
Okay.
So let's talk about relative motion. Relative motion. So relative means it's not like family blood, not that, no. Relative means with respect to something else, with respect to some other person. How is the motion? Okay. Let's say there was a fan here. I'll take only one wing of the fan. Let's say there was an ant at A and there was an ant at B. Fan, it rotates, correct?
Yeah.
Circular motion. If there was a person here, what is the path? Path of ant A with respect to the person on the ground. Let's just see. How will that appear to C? Person C, how will that appear? How is A moving?
A is rotating.
Circular, right?
Circular. Yeah.
Circle.
Mm-hmm.
But the same A, if perceived by B, same A, same ant A,
Mm-hmm.
perceived by B is what?
Straight, because they're both on the same fan.
Yeah, it's as if it is not moving, correct?
Yeah.
Is not circle.
Yeah.
So for A it was circle, for B it was not circle.
Yeah. Circle. Yeah.
So this is called relative motion. So how the motion changes, direction changes or motion with respect to other person, someone else.
Okay.
The formula is simple. We represent it as A slash B. It means that velocity
The velocity of A relative to B.
relative to B or with respect to B
With respect.
or with respect to B, same things, synonyms. So velocity, this is vectors, not speeds. Okay.
Yeah.
So the formula is direct, straightforward, very straightforward. Do you know? A minus B. Okay.
Yeah. Okay.
I mean, you have to add one more reference. A and B means what? With respect to ground.
Yeah. So,
Ground. Okay. like this. You have to write like this. Yeah, this is the only formula. Okay, as seen by B. So they say velocity of A with respect to B, or they can also say velocity of A as seen by B,
Okay.
as, or velocity of A relative
Relative to B. Okay.
to B.
Okay.
Then there can be one more thing, velocity of A as if B were on rest.
Okay.
Okay. So these all mean the same thing, relative motion.
Yeah.
The formula is still A slash B. Okay.
Mm-hmm.
B with A means how will the formula change?
So it'd be V and then B slash A.
Of B relative to A.
Yeah.
B slash A.
Equals. Mm-hmm.
What is the formula?
Equals, so the velocity of B and then slash the ground minus velocity of A slash the ground.
That's it, right? So notice something. If I write A upon B, is it negative of?
Yeah. It would be, right? Because you're switching it around, yeah.
Formula, direct formula. Correct?
Mm-hmm.
Minus.
Yeah.
Any doubt here?
No, that makes sense.
Straightforward, right? So A minus B is the same as minus of B minus A, like that.
Negative and B. Yeah.
So yeah, let's talk about it. See, the formula can be modified also as, see, if there was, let's say, A minus B, we are talking about algebra in general. If I introduce some third party, let's say C, okay, can I write A minus C like this, right?
Mm-hmm.
See, A minus B plus C minus C.
Mm-hmm.
So similarly, if they say A upon B, we know that A VA minus VB, right?
Mm-hmm.
Can I write VA with respect to ground minus what?
Minus VB with respect to the ground, and then minus VC with respect to the ground.
Same, right? What is this formula called?
That would be that would be the velocity of A with respect to C, velocity of C.
Okay. Okay. Minus what? What is this now?
Well, since it's negative, that it would be the velocity of C with respect to B.
Yeah. Or minus VBC. Correct? So it is the same as VAC plus VC.
VC.
So it is a sum of, so VAB.
B.
So it's like C is being introduced in between. Correct?
Yeah.
Can I introduce, instead of just C, can I now introduce C and D also? Let's see how that plays. So A minus C plus C minus B, right? If I introduce C, D also. Okay, so plus D and minus D. So it's like A minus C plus C minus B plus D and minus D. So C minus D and then D minus D. C minus D, D minus See, it's the same thing. C
Yeah.
should be D.
Yeah, yeah. Okay. Mm-hmm.
So this is so let's talk about relative motion. VAB vector should be equal to, how do you write it like this?
Yeah, so that would be the that would be V of A with respect to C.
Okay, vector
Vector, yeah.
plus what?
Plus vector of C with respect to D.
Hmm.
And then this plus, right? So then it'd be the vector of B with respect to D. That's,
See, left minus right, right?
mm-hmm.
Left and right.
But then
A minus C means what? A upon C.
mm-hmm.
So D minus B means D upon.
Oh yeah. Yeah, I see. Sorry.
So it's the same thing. A
Yeah.
and B. Just that if you introduce something else, C D,
Mm-hmm. Mm-hmm. Yeah, makes sense.
like this, like this, like this, like this.
Mm-hmm.
You see what?
Yeah, I see it now.
So they can introduce like questions can be given as, therefore let's say person A is moving with this velocity, some V naught I cap plus V naught J cap. Person B, let's say VA I cap B. Person B is moving like this, person C is some random, person D moving like this. It is basically the vector sum addition,
Yeah.
vector additions. So I'm not going in detail how to do addition and subtraction of vectors because I have already taken the class, right?
Yeah.
But if you want a session, just do let me know.
Mm-hmm. Mm-hmm.
But for now, I'm assuming concepts are clear regarding vectors. Okay.
Yeah.
Hmm. Okay. Let's move on to the next chapter. Fine.
Yeah.
So far we have discussed chapter number 2 is about motion in 1D. Chapter 3 is about motion in 2D. Okay. So 1D was about straight line. Straight line. 2D is about plane. Okay. 3D we don't care. Okay. So let's say there was a ball here on the ground, soccer ball. What do you call it, soccer or football?
It doesn't matter. Both works.
So if he comes here and kicks the ball, obviously it will fly here.
No problem.
It will not go like this,
Mm.
or it will not go backwards.
Yeah.
So what? The direction of the ball, it will go up, and then obviously it will fall down. Why does it fall down?
Because of gravity.
Gravity, right? So gravity is exerting a pull.
Mm. Yeah.
Along what direction? Gravity.
Along the Y.
Yeah, minus y direction, right?
Mm-hmm. Yeah.
So acceleration is minus j cap. Can I write like this?
Yeah. Mm.
Hmm. This is along y direction, right? Can you tell me what is the acceleration along x? Do you see any acceleration?
Um,
Well, gravity is only acting. It's along y direction.
yeah.
So it doesn't have any component along perpendicular direction.
Yeah.
Why? Because dot product, I think you know, is 0 for perpendicular vectors.
Yeah. Yeah.
Okay, so ax is 0. Okay, so along x direction there is no acceleration. That means, what can you comment about velocity?
It's constant.
So v velocity will be, vx will be constant, correct?
Mm-hmm.
Constant throughout the journey, throughout the projectile. This path is
Yeah.
called projectile.
Projectile motion. Yeah.
Okay. So before we go into detail, let's talk about some basics. See, if you, let's say there is a ball here, if it is dropped, initial velocity will be
If it's dropped, initial velocity will be 0.
0, right?
Second.
What path does the ball attain? If the ground is like this,
Mm-hmm.
what path does the ball attain when it is
It'll just down like that. Like,
straight line, right?
mm,
Along acceleration. Path is along.
yeah. Mm.
But if the velocity is not 0, but still if you throw it down along acceleration, you notice something. Let's say 1 meter per second.
Yeah.
What is the path?
It'll change. It'll become like a curve.
See, if it is thrown down, okay,
Oh, just thrown down. I'm gonna straight.
so it will still be a straight line.
Straight down. Okay. Thrown down.
Path will be along A still.
Mm. Mm-hmm.
But if it is, let's say, thrown anti-parallel to gravity, anti-parallel means
The opposite. Yeah.
up,
So thrown.
vertically up, or anti-parallel to
Mm.
gravity. Path will be
Yeah. In the opposite direction, and then it'll have to come down.
so it will come down. This path is called what? Still the straight line, right? See, it goes
Yeah.
up,
Mm.
it reaches a maximum height. After that,
Mm.
it will fall down again.
Yeah.
See, what is happening is the path is still along A. I mean,
Mm.
path is straight line basically.
Oh, yeah.
So these are the three cases where the, what do we say, path will be a straight line. Path is straight line for three cases. One is v0 is 0, initial velocity is 0.
Mm-hmm.
Second thing is parallel to acceleration or anti-parallel
Parallel.
to acceleration.
Mm.
It's not about the gravity, it's about acceleration in general.
Mm-hmm.
Okay. So assuming that acceleration is constant, of course, constant acceleration.
Mm-hmm.
So if v is equal, if v0 is 0, path will be a straight line. But if, okay, let's talk about v0. If v0 is 0 and if v0 is not 0, if v0 is 0 and acceleration is constant, also if acceleration is constant, straight line path.
Yeah.
If v0 is non-zero, initial velocity is not 0, still acceleration is constant.
Mm-hmm.
So we talk about two specific cases where v0 is parallel to A,
Yeah.
v0 is, and v0 is anti-parallel. Path will be
Straight line.
straight line. These are the three cases for straight line. Obviously, every time V will not be parallel or anti-parallel or zero, correct?
Yeah.
So whenever there exists an angle between V and A, there is some angle. Let's say we talk about G. This angle is neither 0 degrees, neither 180 degrees, correct?
Yeah.
0 degrees means what? Parallel vectors.
Mm-hmm. Mm-hmm.
180 degrees means,
Anti-parallel.
see, one vector is like this. 180 degrees means like this.
Yeah.
Parallel means 0 degrees means like this. So, see, what is acceleration role is, whenever you project some velocity, what acceleration does is it tries to mold the path.
Mm-hmm.
Acceleration tries to mold the path onto its direction. Acceleration's direction. This is an important part. See,
Okay.
we already know that when when the player hits the ball like this,
Mm-hmm.
acceleration is vertically down, right?
Yeah.
Throughout the journey, acceleration will be down, you know, wherever the ball is.
Yeah.
In the path, wherever the ball is, acceleration is always pointing what direction?
Down.
Gravity rule pull is always down. So, so it will go up, 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 up. It will reduce its speed, and then it will come down like this. So it is trying to obtain the path of acceleration direction like this. That is why it goes down. So this is what is happening. Even if you, let's say, drop from a, I mean, throw a ball from top of a building, it will go up,
Mm.
it will reduce its speed, and then eventually it falls down like this. What is happening? Why it is falling down? It is trying to reach the direction of acceleration.
Yeah.
The path tends to be uh, the path tends to reach direction of x. Okay. In this case, acceleration is pointed vertically down. That is why it's like that. Hmm. So now that we understood the path, how it will be, so these paths are called projectiles, projectile path.
Mm.
And acceleration due to gravity is
Constant.
constant. So A vector is minus G J cap. So to summarize, if you if V naught is not zero, theta is not 0 degrees and 180 degrees, this path,
Yeah. This path will be projectile
good.
path. Motion.
Yeah, path or motion center. How it is moving means
Mm.
motion.
Mm-hmm.
So okay, come to the next page. Yeah. Throughout the path, what did we observe is it is given some velocity, well, let's say 1 meter per second. Okay, it will go up with the maximum height. What is the velocity? Y component of velocity. Obviously, it will not be 1, right?
Mm-hmm.
It will decrease a bit.
Yeah.
So velocity is changing. Velocity changes with respect to time.
Yeah.
Okay. With the time, velocity changes. That is yes. What about acceleration?
No, it's constant throughout, right?
Yes. Acceleration doesn't change with time. So one more point is, I think you already know this. Acceleration molds the velocity or the path
Yeah.
towards its direction.
Towards its direction.
This molded path is projectile. Acceleration is like this. If you give initial velocity like this, it will go up, it will fall down. This path is projectile.
Mm-hmm.
Okay, let's talk about components of vectors. Okay, let's say if this is v naught vector, it's making a angle of theta with horizontal. What is the x component and what is the y component of the vector?
So it'll be the length of the vector, and then cosine of theta will be x. And then the y component will be the length of the vector, and then sine of theta.
See, I'll tell you a trick. Okay,
Mm-hmm.
let's say it's this vector has 5 centimeter length. Let's say if the angle is, let's say 37 degrees. Okay,
Mm-hmm.
onto which direction you are projecting the component? Let's say if you are talking about this component length will be 5 cos theta. Okay,
Yeah.
and vertical component will be, can you guess?
5 sine theta.
Theta. So it doesn't stop like this, x and y. See, let's say if there is a triangle wedge here and the ball is projected something like this. This angle is, let's say, 37 degrees. If you are talking about this direction, if you want the velocity component on this direction, 5 meter per second velocity, if you command the component along this direction, this, that component of vector will be,
That would be the x.
this vector. I'm not talking about x component, this vector. See, up to here is the 37-degree angle, right?
Mm-hmm.
So 5 cos 37. The perpendicular to it will be 5 sin 37.
Mm-hmm.
So where you want to know the component, that angle you have to find first, and 5 cos of that angle will be horizontal, vertical will be sine component.
Mm-hmm.
So any vector can be written as cos theta I cap plus
Sine theta j cap. Like the length, and then
yeah.
sine theta j cap.
So v vector can be written as v naught cos theta I cap plus v naught sin theta j cap.
Mm-hmm.
So horizontal component is v naught cos theta, vertical component is like this, correct?
Yeah.
So let us understand the diagram a bit better. Scroll down. So this is, let's say, v naught and this is theta. So this component is v naught.
Y or sine theta.
Yeah, y, v naught y. Okay, and this component is
V naught cosine theta.
okay. See, any complex problem comes, we first break down into multiple parts. So far we have understood how to solve questions when the motion is a straight line.
Yeah.
That means along one vector direction, I mean one component direction. One direction problems we have done in 1D.
Yeah.
See, 2D means it attends one component and it also attends another component.
Mm-hmm.
So let's say if it is x direction for the previous case, there's also x for 2D, but there is also y for 2D. So x component I cap plus y component j cap. This vector sum gives us
The total vector, the 2D.
so 2D. So whenever this velocity, acceleration, things like that, they're all vectors, right?
Yeah.
So when they have both the components, deal with them individually along y and along x. That is the play. That is the strategy. Along x direction and along y direction. So you break the components along x direction, break the components along y direction.
Mm-hmm.
So what is exactly happening along x and y? Let us understand that first. Okay. So yeah, same case. If you take the ball example, if it is given a velocity v naught with theta angle, the path will be like this, correct?
Yeah.
Okay. What is along x direction? Initial velocity is how much?
0 meters per second. And then you're kicking the ball.
So the velocity given is v naught. Okay.
Mm.
X component is, you have to break the component. This is the vector. You have
Yeah.
to break it into two parts like this. This
Mm-hmm.
one and this one.
Mm-hmm.
So along x direction, initial velocity will be this component, right?
Yeah.
That is how much?
Oh, V naught cos theta.
V naught cos theta, right?
Mm.
So magnitude of this velocity. What about y direction? What is the velocity? Let's say v naught y,
V naught
right?
sin theta. V naught y so equals V naught sin theta.
Good. So this is the initial velocity. Along x direction, what is the acceleration?
Mm. 0.
0. If acceleration is 0, what do you understand? What can you comment on velocity?
Velocity will be constant, so same throughout.
So wherever the ball is, okay, its x component
Mm.
doesn't change, constant velocity.
Yeah.
Along x direction, the play is along x direction.
Yeah.
So whatever the path you take, the velocity will be, x component of velocity will be
Constant.
v naught cos theta. Okay.
Yeah.
Yeah, constant only, v naught cos theta.
Mm-hmm. But V naught cos. Yeah. Makes sense.
Okay. What about acceleration along y direction?
It'll be equal to gravity, so 9.8 meters per second, or negative. Yeah, because
F
it's
g, okay.
sorry.
Because g can be approximated sometimes as 10, not just 9.8.
Mm-hmm.
So just leave it as g. So minus g j cap, correct? J
Yeah.
cap. So along, so magnitude of the acceleration is g, which is constant. Constant acceleration. So along the y, there is a constant acceleration. Can we use equations of equations of motion. If acceleration is constant
Yeah.
and if acceleration is 0 here, so along x, acceleration is 0. So velocity
Mm-hmm.
is constant throughout the journey.
Yeah.
At any point, x component will be same v naught cos theta.
Mm-hmm.
Okay. Yeah, constant acceleration. Acceleration is constant means equations of motions can be used. We have the formulas. V naught is equal to V naught x plus V is equal to V naught plus 80, right?
Mm-hmm.
Like that. There are 3, 4 formulas.
Yeah.
Equations of motion can be used. So can we? So do we have a strategy to deal along y direction now?
Yeah.
And do we also have a strategy to deal along x direction?
Yeah.
So speed is constant means what? Can we use the formula speed is equal to or velocity is equal to distance upon time.
It's over time.
This along x, distance is equal to displacement because 1D dimension, 1D direction.
Yeah.
Displacement is equal to distance along x, that is.
Yeah.
So speed is equal to distance upon time, or let's say v naught cos theta is equal to distance upon t, like this.
Yeah.
So this formula can be used. This is the only formula for x direction. So for y direction, it's a bit complicated, but we know how to deal with. What do we say? Equations of motion, constant acceleration concepts. So can be used. So this is about that. So let's talk about equations of motion. That is along what direction?
The y direction.
There is no acceleration in x direction. Okay, let's before we proceed, let's say velocity particle velocity is v naught. At some random point, pick a random point on this projectile. Quick.
Okay.
Hmm. Okay. At some random point, can you draw the velocity direction also?
The velocity direction.
Direction of velocity at this point, instantaneous velocity. How will it move at that point? What is the velocity? See, do you remember that when you are talking about circular motion, when the particle is moving clockwise, if I randomly pick a point, what is the direction of velocity?
Uh, it's the same way the circle is moving, so clockwise. I guess.
Tangential direction, okay?
Mm-hmm.
It is moving anti-clockwise. Direction will be how? Can you draw it? Okay. This is for anti-clockwise. For clockwise also draw it. Okay. So that is v vector. So similarly, it will be along the tangential direction, okay? The velocity vector.
Mm-hmm.
Not the x component, y component. The full component will be along the tangential direction. Draw the tangent here. Okay. So obviously the speed changes, correct?
Yeah.
So let's say speed at here is v. So this angle was theta, but obviously this inclination may not be theta, right? Along horizontally, this angle may not be theta. This was theta. So let's say we say that angle as, let's say, some theta dash, okay, or some alpha or beta.
Yeah.
Let's say beta.
Okay.
See, what is common between these two? Acceleration along x is how much?
0. Yeah.
So what will be same?
Their acceleration.
Acceleration is 0. So it moves with constant what?
Constant velocity. Yeah, sorry.
So
Yeah.
Vx will be
Velocity.
same.
Yeah.
So can I say V naught cos theta should be equal to what?
V cos theta.
Cos
Theta prime and the other one
beta.
cos beta. Okay.
Okay. So this is a condition, okay? So the theta value is changing with the time. But still Vx is
Equal to V naught.
remains the same. X component of velocity remains the same. What about Vy though? Will it be same?
No.
Because Vy means along what direction?
Along the y. So because acceleration is constant.
Yeah. Because of I'm writing Ay is equal to minus g j. Acceleration changes, Vy changes.
Yeah.
Okay. So these are some basics. Let us understand how equations of motion will be there. The equations. Let us study them. Okay. So there are some words which are important to remember. If you throw a ball in this direction, the path is a projectile path. Will prove it. I'll prove it later that this path is a parabolic path. Okay. So horizontally, the max distance it can cover horizontally. This is called range. Okay. Range or R max, same thing. R max, same thing. Capital R. Okay. And can you spot the maximum height? Where is it exactly? Is it here, here, where?
Next page. Sorry. Maximum height would be like here, like at the very top peak, like at the top of its path.
Yes. So this is the maximum height, H max. Make sense?
Yeah.
Let's say this is t equal to 0. At this instant, just the beginning, t equal to 0. Here to here, time taken is t. Okay? Duration is t. Let's say initial velocity is v now. Okay?
Yeah.
We already discussed that we deal with two separate directions, x component and y component. perpendicular directions.
Mm-hmm.
So in x direction, velocity speed doesn't change. Okay,
Yeah.
speed is equal to in x. What formula can be used? Speed is equal to
Distance over time.
distance. So for time t, how much is the distance covered? Here to here, right?
Mm-hmm.
So that is we call range. Range upon
The range of
time.
hunt. Makes sense. Okay.
So time, capital T is time of light. See, obviously, see, instead of assuming the entire ball is moving like this, what we did was one component moves like this, one component moves like this. It's the same as assuming there is a small ball moving like this direction, another ball moving like this direction.
Yeah.
So the one ball goes up and comes down, while other ball goes like this.
Mm.
Both reach the ground at same time. The y component and x component.
Mm-hmm.
So that is why t is called time of flight. Total time taken.
Yeah.
This ball goes like this, it reaches down. It takes time t. This horizontal ball also goes like this, it takes time t.
Exactly.
You understand this?
Yeah.
Hmm. Yeah, so r upon t. Okay. Okay. So in the y direction, there is an acceleration. Let's say we consider the journey from here to here. Okay. Initial path to this path.
The highest point. Okay.
At highest point, what can you say about Vy?
Um,
Final velocity at highest point. See, it's like I told you in y direction, there is a small ball. It is going up, right?
Yeah.
See, what does it mean by maximum height? If it goes up like this, like this, like this,
Mm-hmm.
at some point it has to change its course and start falling down, right?
Yeah.
That means no gas left at top point. Do you understand what I mean?
Mm.
So that means velocity at this point has to be how much?
Zero.
It's exhausted, right?
Mm. Yeah. Okay. Yeah, and then it starts falling. Okay, so it will
Got a similar case.
momentarily be zero at that point.
So final velocity, can I say 0? Vy along y direction, of course.
Hmm.
So Vy is 0. And V0y was how much? Initial velocity along y.
V not sine theta.
But V0 sine theta, okay?
Hmm.
Yeah, V0 sine theta. See, this type of questions, I think you got one in the homework. If the particle goes like this, for it to change the course of its direction, velocity has to be 0 at this point. So particle is decelerating. So that is why velocity became 0, and then it is coming in this direction, left side.
Hmm. Okay.
There was a question on graphs like this: A, B, C. This is V versus T
Yeah.
now.
Mm-hmm, mm-hmm.
So you have choose the correct option. That is fine. So here to here, speed decreases. So all
Yeah.
those things. Acceleration is constant.
Hmm.
So
Yeah.
Yeah, that is what exactly is happening here. It goes up, but it falls down. For it to fall down, for it to reverse its path, velocity has to be zero. At what
Yeah.
point exactly? Maximum height it can attain. This is called maximum height. So it's the same thing. So we are talking about here to here, correct?
Yeah.
So v naught y, initial velocity is v naught sine theta. Final velocity in this from here to here is zero.
Yeah.
So what about acceleration ay is how much?
Negative g j cap.
Or negative g. So it's important to place the coordinate system. So let us place the coordinate system as common at the initial point, okay?
Yeah.
Place the origin at initial point. So from there, you assume the positive and negative signs. So we were talking about constant acceleration. So equations of motion. How will that play out? Tell me. What is the first formula?
V equals v naught plus at.
Plus 80. So if we are talking about what direction?
The y direction. So vy equals v naught y plus a y.
Okay, now tell me, plug and play.
So then v naught y is v naught sine theta.
Good. Positive or negative? Is it positive or is it negative? Which one is it?
Positive.
V naught is along like this, right? This is the V naught sine theta. So we place the coordinate axis like this. So this direction is obviously positive. So V naught sine theta is positive V naught sine theta.
Yeah.
Sign convention is important. So what about AY?
Minus gt.
Minus GT, okay? So T is equal to how much? Simplify this, find the value T variable. Right there. Yeah, V naught sine theta upon G. V naught sine theta is V naught Y upon
V
G.
naught y.
Okay. So this is about first formula. What is the second formula in equations of motion? So this is a formula. Substitution gives this. So what is the formula for H max? H max. Okay, so V naught Y upon 2G.
Yeah.
So these formulas are important. Like there are three things: range, H max, time of flight. They are important. Okay. So one thing that drives our range is
Sorry, what was?
well, there was no question. I'm telling you.
Oh.
One thing that determines the range, the horizontal range, how far the ball goes, is that it is actually driven by horizontal component of velocity.
Yeah.
It is big, the range will be big.
Big. Yeah.
Small, small. So V naught x determines. So V naught x is responsible for horizontal travel or horizontal range.
Yeah.
So we just got H max. Can you use one more equation formula? I mean, so far we have used v equal to u v naught plus gt, v naught plus at, and v square minus u square, v square minus v naught square is equal to 2ax. What about the third formula? X is equal to
x is equal to v naught t plus half at squared.
Okay. Yeah, so I'm writing it here. Slightly scroll up. So x naught plus what? What is the formula?
So x naught plus
X minus x naught is equal to
x minus x naught equals v naught t plus 1/2 at squared.
So if you are talking about y direction, so y minus y naught like this.
Yeah.
So yeah.
So this will be
X minus x naught is how much? Did you find that already?
it will be the h max, right?
Good. H max. We just did right? 2a x minus x naught. So h max is equal to
v naught y sine theta.
v naught y is how much?
V naught sine theta.
V naught sine theta times t, right?
Times t. Minus 1/2 gt squared.
Gt square. Okay. Yeah. I mean, if you talk about in general, y minus y naught should be equal to v naught t plus half ay t square, right? So y minus y naught. If you say if you place the origin at the initial point, y naught is 0. So y is equal to v naught y minus g by 2 into t square, right? Yeah, so basically character limit has been reached.
Yeah. But no, I know what you mean.
So basically what I'm saying is something into t minus g by 2, that is also something in some number, right?
Yeah.
To t square. So y versus t graph will be parabola.
Parabolic, yeah. Okay.
Upward or downward?
Downward.
Downward. So inverted. So this is the path.
Yeah.
The projectile. So I told you, right? What did I say? The projectile path is a parabola. This is a proof, mathematical proof. So let's talk about parabola, okay? Yeah, I'll wrap up quickly. So come to this question background at the top.
Yeah.
So basically, this point acts as axis of symmetry because this is a vertex.
Yeah.
So whatever you see on the left side should match with the
Right side.
right side, right? Can I say if this total length is r, here to here it will be
R by 2.
So the x displacement or distance traveled along x from here to here
Will be R by 2.
and time taken to reach from here to here will be the same as
the time taken to reach from that point on to the end point.
Okay, we just solved for t value, right? Here to here.
Mm-hmm.
If you double that t value,
Mm-hmm.
2t,
Then you'll get the total time.
2t value. So capital T, time of flight.
Yeah.
So we can discuss more about that in the next class. Okay.
Mm-hmm.
I thought to complete this in this class, but okay, I'll try to complete it next class. Okay.